So now what we're going to do is look at what's called the ambiguous case for using the sine law. So if you were paying attention to the end of the previous video, I talked about how because sine is not a one-to-one function on the interval 0 to 180. So again, I'll just redraw what that graph looks like for you. Right, so between 0 and 180, this is what the graph looks like. It's not one-to-one, which means that if we have a sine ratio of a particular y value, to do the reversal, what it will always do is take you to the smaller of the two outputs, and that's what it'll give you. It'll give you that original input that was between 0 and 190. So using arcsine for these numbers that we're going to have here will always give you a number between 0 and 1 and 90, even if that's not what you want. So we're going to go through a few of these examples here. And we should encounter, I think, everything that can possibly happen with using the sine law to solve for an angle. So for the first one, we've got a's and b's. So I'm going to set up the sine law for a's and b's to solve for angle B. So I will have sine B over little b, 2.6, is sine 63 over 3.1. And so solve for sine B, 2.6 sine 63 over 3.1, plug it in the calculator. Divided by 3.1 is 0.7473. And I'm going to use the inverse sine to solve for that. And I get 48.3 degrees, actually 48.4 if I round that up. So 48.4 degrees. And so using the sine law, as I mentioned, sometimes we can have two answers. So this is the answer that I got if I take this picture and move it down here. So this answer that I got here would be my 48.4 degrees, which would be that distance there. And so by symmetry, it should be the same distance to get the other potential answer. So it would be 180 minus 48.4. Yeah. And so I could figure out the other answer for that. So what I'm going to call them is B1 and B2. So 180 minus 48.4. And if I actually do the math there, what I end up with is 131.6 degrees. But there is a little bit of a problem. If I look at the angle A, it's 63 degrees plus this 131.6 degrees. So if I do A plus B1, what I get is 194.6 degrees. That's too big for a triangle. There's too many degrees in this triangle. So we actually get to reject the answer B2. So we only really want the 48.4 degrees. That's our only solution for this one. All right, so that's going to be kind of the idea. Basically what you do is you use the sine ratio as normal to get your first angle, and then see what happens if you do a 180 minus to get a potential second angle. All right, the next one, it's going to be B's and A's again. So I'll set it up. Sine B over, I'm going to plug in the number 21 equals sine A 21 over little a. So sine B is going to be 21 sine 21 over 14. Which is 0.5376. And so I'll do B I'll tell B1 is the inverse sine of 0.5376. And we get 32.5 degrees. And so my potential B2, just follow the same pattern, looking at that picture using the symmetry, it would be 180 minus 32.5 degrees. And if you don't like that picture, the written notes also have a second explanation for what this alternate angle should be. And so the other possibility is 147.5 also. And so what we're going to do is that check. B1 should always be good. We don't have to check if B1 works, but B2, because it's bigger, it might introduce those problems. So I'll check A plus B2 would be 21 plus 147, so 168.5 degrees. That's okay, so we can accept that. So these are actually two different possible answers for our B. The two of them are both good. So that is a possibility. So yeah, maybe up above what I'll do is actually just draw you what these two triangles are going to look like. So if we start with the side length of 14 and the 21 degrees, so that's kind of fixed in both triangles here. So a side length of 14, I'll try to make them look about the same. An angle of 21, so it should be the same angle. And then if this is, oh, sorry, that should be, I'm going to leave this as a little b on the bottom, as we, right. And then this is going to be A. And then the idea is, so yeah, so this is going to be little b. And then the opposite side over here is going to be the little a. And so we need to draw that. And the idea here is that there's two different ways that we could draw this to connect with that 21. So it should be, I think this would look like one of them. So that works. And then this one gives you this great big wide B value. This is actually the 168.5 degrees. That's actually your B2. And then in the other picture, we could actually extend this much, much further and also get the 14 to meet up here. And so in this case, now my B is a little bit smaller. This is the B1 is 32.5 degrees. But both of those ways that I've drawn the 14 should work for this picture. Both of them will close off this triangle in a meaningful way, and it creates two very, very different triangles with two very different opposite angles. So that's what's going on here, and that's why we get the two answers. Okay, so for this last one, I'm going to set up my ratio with C's and B's. So sine C over little c 50, oh no, I know. Sorry, I was doing sine B there. Over 71 is sine 55 over 52. So sine B is 71 sine 55 over 52. And I get a 1.1185. So B is going to be my inverse sine. And again, you should be getting a calculator error for this. In this case, there is no such triangle. That is a possibility as well, just like with the cosine law. So what would be going on up here in this picture? I'll draw this in maybe green. So what's going on here is if we draw kind of the same thing here, so our B is 71, our angle is 55. And the problem is that this length here of 71 is going to be just too long, because I know that the little side C has to come from over here somewhere. It has to connect with B on the right side. And it's just not going to be long enough to reach out to that opposite side. And so we can't close off the triangle. So that's another possibility that you're going to occur. So the triangle doesn't work, and that's what we're going to get. So I just want to do one more question with these. Oh, yeah. So just for this last question, this is more in line with what you'll probably expect to see in applications or any questions. So you'll be given a picture of a triangle and asked to solve for the angle in the triangle, so that theta there. So yeah, going ahead, I'll need some kind of labeling to be able to set up my sine laws. So let's say I'll just call this A is theta, so this will be my little a, and I can call you B and B. And so I'll set up my sine A over A is sine B over B. So that'll be sine theta over 38.7 is sine 35 degrees over 24.3. Solve for sine theta. And plug that in, and we will get a nice decimal, excuse me, times 35 divided by 24.3. 38.7 times sine 35 divided by 24.3 is 0.9135. So theta, I'm going to undo that. And we should get about let's call it 66 degrees. Now, if you're not paying attention, you would just write that as your answer. But it's not in line with the picture. We can definitely see from the picture, A is bigger than 90 degrees. It is definitely an obtuse angle. So your pictures are not going to be perfectly to scale, but whether something is smaller than or greater than 90 degrees will be accurate. This is bigger than 90 degrees for sure. So this is not right. And hopefully that's the mental trigger that you need to realize that I need to find the other angle that satisfies this sine ratio. And that's just 180 minus. So the actual answer will be 180 minus 66, which is 114 degrees. That is your answer for this question. That should look decent with the picture that I've given. So try to look out for that. It's always a worthwhile exercise to make sure that your answer looks or sounds right in the context of any question. So this is just further emphasis of the value of checking answers.